Hello, my name is Nilesh. As part of the Cloud Native Ninja series, today we are going to continue and see how to use Kubernetes Ingress. So far in this series, we have talked about what are the different aspects related for containerizing the application using polyglot programming model. We have created multiple services or APIs, TechTalks producer and TechTalks consumer, and we have used a distributed application runtime named Dapper in order to decouple this, and we communicate using RabbitMQ as our messaging infrastructure. We also built TechTalks UI as a front end. If you have not seen the earlier parts of the series, I recommend that you have a look at these if you are not familiar with some of these concepts that we have covered as part of this series. In the last part, we looked at Kubernetes service, which allows us to expose our application over the network. And in there, we had looked at what are the different options using which we can expose a Kubernetes service like a cluster IP using the public cloud provider provided public IP, and also as node port and as the named service. In all this, we were using port forwarding, like in case of the cluster IP example that I used, we were using the node forwarding or port forwarding option to forward the traffic to our service. Today, we are going to look at one of the options which is called as Ingress, which allows us to manage the external access to our services in the cluster. This is typically done for HTTP and HTTPS traffic, and Kubernetes provides an API object called as Ingress for this. However, it does not provide an implementation of the Ingress. It is up to the users or the end users who use this facility to provide an implementation of an Ingress. In this diagram, we can see a small example or how does this traffic flow from the client or the end user through a load balancer into an Ingress, and then that Ingress manages the direction of the traffic to the right service. The advantage of this is that we can have one public endpoint for all our services, and we don't have to expose each and every service in our application using concept or using a thing like load balancer, which creates a public IP for our service, but then every service doesn't need to be exposed over its own individual public IPs. Using one single public IP for all the applications or all the services in related to our application, the Ingress can route the traffic accordingly, and it can do things like the SSL termination. We can send traffic using SSL, and that can be terminated at the Ingress level, and the traffic between the cluster or services within the cluster can happen without the SSL. So let's look at this, how we are going to use this Ingress for our application, the Cloud Native Ninja series that we are doing. Let's head over to the code and see what is required for having the Nginx Ingress. There are multiple Ingress solutions available, and in this video we are going to look at Nginx, which is one of the popular web server which can be used as a reverse proxy to set up the Ingress capabilities for Kubernetes. In future videos of this series, we might see other implementations like the Azure Application Gateway, which can also be used as an Ingress. So I have a Azure Kubernetes cluster or AKS where I have deployed the producer and consumer services for my application. And here is how the service for the producer is deployed. It is running as a cluster IP, which means that it can only be accessed from within the cluster, and it is running on port 8080. The first thing that we need to do in order to have Nginx deployed on our Kubernetes cluster is to use one of the way in which the Kubernetes, Nginx can be installed. So for that purpose, I'm using a Helm chart. I've done various videos on this channel regarding Helm, and I use Helm for deploying third-party applications onto my Kubernetes cluster. So here we start by having the repository added for Ingress Nginx, which points to the kubernetes.github.io, and the repository name is ingress-nginx. Then we do a Helm repo update, and finally we run the Helm upgrade and install command with install flag, and we pass the name, or we create the Ingress or a Helm release with the name as app-ingress using these parameters. Now, when I'm deploying this to Azure Kubernetes Service or AKS managed Kubernetes instance, I need to set this property on the controller to expose this using the external traffic policy as local, which means that the traffic which comes into the Kubernetes cluster will be treated as a local traffic once the ingress starts redirecting the traffic to the backend services. So let's go ahead and run this particular PowerShell script. These are actually kubectl or Helm commands, so they can be run as normal bash script as well. And we are going to deploy Nginx. That's the script we are running, which will perform those 3 steps to add the Nginx repository or Nginx Ingress repository to our list of repositories. Then it will upgrade the repo, and then finally it will run the installation by using the command which is Helm upgrade and install. So here we are seeing that the release app ingress, that's the name of our release which we are using, does not exist on our Kubernetes cluster, and it is installing it now. Once this is installed, we can verify what are the objects it is creating. So once the installation of this Nginx Ingress is completed, we get this documentation or what is the next step which is required for us to use it. It says that there is a load balancer type service created, and we can get this status of this running service and see if the public IP is created for this, because it takes some time to provision the load balancer. It uses the load balancer capabilities or creation of load balancer of the public cloud, which is Microsoft Azure in this case. Let's run this command to see if the public IP has been assigned to our service. And if we have the external IP assigned here, which is 4.144.184.74, that's the public IP for our load balancer service created for our app ingress Nginx controller. We know that now we can access our service using this particular external IP. So let me copy this IP address because we will be needing that in the subsequent steps, and then we will use it to configure the ingress. So I'm going to update this public IP here. Once we have the Nginx Ingress created, we can look at the properties of that, or we can describe this and see what are the properties which are set for that. So we looked at the get part. We ran the kubectl namespace default get service command or get services, and we know that there is this app ingress service. Let's go and see the details of that. So we can run this command to describe the details of our service. Kubectl get services or service, and then the name of the service, which is app ingress ingress Nginx controller, and we want to output this as YAML. So this gives us the details of this service which is created by the Helm chart, and we see all the annotations, the creation time, the labels that are assigned to this. We see that it is having this managed by Helm, and the name of that ingress is Ingress Nginx, and then we see the cluster IP, which is the same thing that we copied from the external IP, which is assigned, and the type of this service is load balancer. We will also see that the internal traffic policy is cluster and the external traffic policy is set as local. So with that, we are set to use the Nginx Ingress. The next thing we have to do is to create the Ingress Rule, or a type of object which is of type Ingress. Here we are creating the kind as ingress, and we are providing the metadata to say that the name of this particular ingress for my application is TechTalks Ingress. We provide annotations to say that I want to use regular expression and I want to rewrite the target. This will come handy when we specify the rules for redirecting the traffic. In the specification, we specify that the ingress class name we are using is Nginx. If we are using other supported ingress like the HA proxy or traffic, the Ingress class name would change accordingly. Since we are using Nginx Ingress here, the name of that class is Nginx. Then we specify the rules, which is a collection of the rules to say how traffic should be routed when the Ingress gets a request from outside of the cluster. We are specifying a HTTP rule here, and then we add the paths. We add a path to a service called producer, or we are defining a path here /producer, and then whatever comes after that, we are mapping that to the placeholders. The path type is prefix. If I have a Visual Studio Code extension here, which gives us what are the other alternatives for path type. This is a Kubernetes extension, which is part of the Visual Studio Code, and it tells us that the path type can be of two types. One is the prefix, what we are using here. The other one could be exact match or exact. If we use exact, that means we will have to specify the exact path. Whereas in our case, the service that we are using, RabbitMQ producer service, it has a parameter which takes the number of messages that needs to be created. So for that reason, I'm using prefix here, which allows me to do this routing based on dynamic variables. And then the backend configuration says that the service that I'm targeting for this particular /producer path is RabbitMQ producer service, which runs on port 8080. Once we apply this, then we will be able to use that public IP to query our service or to send traffic to our service. So let's go and apply this particular Ingress rule. So I'm going to use deploy TechTalks Ingress, which is a PowerShell script again. And here we can see that the TechTalks Ingress deploy has been successfully created. And if we go and do kubectl get ingress, we should have a ingress named as TechTalks Ingress. So this tells us that the Ingress rule has been created, or the Ingress object has been created. With this, we can now go and send traffic to that particular service. And I'm going to use another of the extension for Visual Studio Code, which is the REST HTTP, which allows me to send get or post request from Visual Studio Code itself. When I send the request with these parameters, which says that this is the public IP that I'm using, then I use the path as producer and then generate, and 1000 is the number of messages I want to create. Here we get a response that successfully produced 1000 messages. That is the response this particular service sends when the 1000 messages are created. And if I go into the RabbitMQ UI here, we can see that the 1000 messages have been published to the queue. So with this, we are able to see that using an ingress, we are able to expose a service which is running as a cluster IP service outside the cluster using a public IP. Now let's head back to the presentation and see what did we do as part of this. So during this demo, we saw that on the Azure Kubernetes Service AKS cluster, we have deployed our application services, and then we deployed a Nginx Ingress controller, and then we applied the Ingress rule to route the traffic which is coming from outside the Kubernetes cluster using the public IP to route it to TechTalks producer using the producer as the path. And although the service runs on 8080 port internally within the cluster, I don't have to specify the port when I submit the request or when I send the request, because that routing happens as part of the route mapping which the rule specifies. And with that, without specifying the port number, I am able to send the traffic, or I'm able to route the traffic to the right service within my cluster. So here are some of the key features of Kubernetes Ingress. We saw the Ingress controller, or the one which is created as part of Nginx Ingress installation using the Helm chart, which is used for managing the load balancer and the reverse proxy configuration to route the traffic to the appropriate service. Then we also have the rules and the paths. So if we go back to our Visual Studio Code and look at the YAML file again, we see a collection of rules here, and we see the collection of paths, which allows us to define multiple rules and multiple paths. Here we are specifying only one service, but I do have another example where I have multiple services in my application. And in that case, I'm defining a different ingress configuration using a similar kind of setup where there is a route for account service, which is running on port 8082. Then there is another route for authentication service running on port 8081. We have the backend service running on port 8080, and we have the forex service running on port 8083, and finally a transaction service running on port 8084. So here we can see that using one ingress, we are configuring the routing to 5 different microservices. That is the advantage, or that is the benefit of using Ingress, which allows us to define these rules and paths, and we can do this different redirects and rewrites to have custom routing. And we can also do TLS termination. I did not cover the TLS termination part in this particular video. I'll cover it in one of the subsequent videos, but we can have the Ingress resource to configure the TLS certificate and how it handles the termination of TLS at the edge of the Kubernetes cluster, and then services are still able to communicate within the cluster. In terms of the best practices, here are some of the best practices related to the Ingress. First one is about using the managed Ingress controller, where the recommendation is to use a well-maintained and community-supported Ingress controller like the Nginx Ingress controller, which we saw in this case, which is one of the most popular Ingress. There are also other options available like Traffic or HA proxy. These are often updated with the latest security patches, and they also come up with new features from time to time. The next best practice is to define a clear naming conventions. Ingress allows us to define the resources and the rules based on our application. So it is better to start with a clear, well-defined naming convention when we want to create new Ingress rules for our application. The other recommendation is also to split the Ingress resources into smaller Ingress rules. Avoid creating one big single file which contains all the Ingress rules and the paths. It is better to always have multiple ingresses and separate them based on the type of the application or the service. From a security point of view, it is also recommended to use role-based access control and to implement high availability. The Nginx Ingress controller, which I showed here using the Helm chart, has a capability to deploy multiple replicas of the pod which runs Nginx. So that is one way in which we can ensure that we have reliability and fault tolerance built into the Ingress solution. With that, we have come to the end of this video. This is, as I said earlier, part of the Cloud Native Ninja series. You can see the complete working code on GitHub. You can scan this QR code as well. And all the commands that I showed during this particular video are available as part of a markdown file. You can use this link to access this particular markdown file. It will also be available in the description below, and the slides are published to SlideShare and Speaker Deck. I hope you found this useful. Thanks for watching this video. If you find this content useful, please hit the like button, subscribe to my channel, and do share it with your friends. Until next time, code with passion and strive for excellence.